Hello and welcome to this course about Git step-by-step guide. Thank you for enrolling this course and learning Git with me. My name is Başar Büyükkahraman. So let's start with the first question. What is Git? Git is simply a distributed version control system for managing source code. Let's explain this a bit more. The version control system is for tracking changes to files, as we do changes in our files like modifying, removing files, or adding new ones. The version control system is saving all these changes, and it allows us to restore a previous version of our code. And by saying distributed, rather than having only one single place for the full version history of our files, every developer can have the full copy of the repository in their local environment. So with Git, you can almost do all of your work without needing to connect to remote repository. Now the theoretical description part is done. Next, we will install Git and start using it. Now let's install Git to our operating system. You can find the latest Git installation right here. And currently Git has this version 2.29.1 and released on October 22nd, 2020. And you can choose the operating system of yours. I'm going to download for the Windows, and I already downloaded this one. Here I got the setup, running this one. And in this wizard, clicking next. This is pointing the installation directory, going with the default, and it is asking which components we want to install, and I'm leaving the defaults as it is. And it is saying to create the start menu folder, and now we are going to configure our Git. Later we will be able to change these configurations, but let's go over them. Here it is asking us the default editor, and here we have the lists. Let's go with the default, the Vim. Later we will replace it something else. And it is asking us what should be set for the default branch name until the version 2.28. By default, Git was creating the branches, the default branches as the name master. But after that version, now it is asking us to set a name for the default branch. So whenever we create a repository, the Git is going to be creating default branch with this name. Well, this configuration can be also overridden later. So leaving as this. Git is coming with the Git bash, but we don't want to be limited to that one. So going with this recommended option. So it is basically adding Git to our environment path, so whenever we open our terminal, we will be able to run the Git commands there. And this is for the SSH part, again going with the default. Same thing for this one. And based on your operating system, this option is different. If you are running on Windows, you must be checking this one, this checkout Windows style, and commit Unix style line endings. And this is another configuration that we can set it to different value, and this is the configuration parameter right here. And if you are running macOS or Linux, then this option must be checked for you, and corresponding configuration is core auto crlf to be input. And going to the next part, again going with the default right here for the emulator, and this is the Git pull functionality behavior, again going with the default. And this is the credential helper. When we are working with the remote repositories, we would be using our credentials to log in those repositories, and this is asking us where to store the credentials, and going with this default one again. And this is also the default, and now we can install the Git. And finishing this installation wizard. Now, I've opened the command prompt and running git --version. And here we see the Git version is 2.29.1. Git installation is coming with bash. Let's open that one. So here we have the terminal. The bash is coming with Linux commands, so we can print the directories like print working directory, or we can switch to upper directory. And here it is adding the corresponding directory like this. By the way, you may have different type of output, and you can change it from this file. The file is located right here, program files, git, etc profile d, git prompt sh. Here, this part is the representation of the output. Let's put it right here. And let's also change the size of this font right here. Let's say the font size will be something like this one. So we have a bigger output. And right here we have the terminal, and here we have the corresponding fields. So this one is starting with a new line. As you can see, we are starting with a new empty line. Then we are typing our user with green. Then we are switching to yellow, and it is typing the path. This is user home directory, and this is the other directories. And if there is a Git repository in one of these folders, this output will also include the branch name here, or if we are some kind of in progress of merge, the rebase or anything like that, it will be printing out corresponding status. So if you would like to change this part, you can use this file. In this course, we are going to create a simple HTML page, and in this page we are going to create our own Git cheat sheet. And throughout this course, we will learn Git commands, and we will apply those commands on our project. You don't have to know anything about HTML or CSS or JavaScript. This course is not going to go deeper in that areas. We will just use this as a sample project, and we will do our implementation in this Visual Studio Code. And again, in this Visual Studio Code, I will be using the terminal here. So here it is saying toggle terminal with this one, or you can show it like this, show panel. It has this terminal tab. And for me, it is by default the bash, which is coming with the Git. And here we have the output. And if it is not this one for you, you can go to this select default shell part and select the Git bash from here. Now we are ready. Let's learn how to use Git in a project where we need to keep track of our change history. In this course, we are going to build a Git cheat sheet with HTML and CSS. And while doing that, I will be using Visual Studio Code. Later, we will see its built-in functionalities for Git, and we will also see a couple of extensions. We will be doing all our Git operations on command line, but with these extensions, we will get the best out of Git, and that is going to increase our productivity. To follow this course, you can use any text editor you like, but if you are not already using Visual Studio Code, I highly suggest you to try it. If you need to install, then you can download from here and follow the installation wizard. Now we have Git on our system. Let's start with configuring it first. We have seen some of the configurations through the installation. For configuration, we will use Git Config functionality. This configuration can be stored in 3 different places, and this system configuration is applied all the users in the operating system. To set system-wide configuration, we may need admin or super user privileges. And then we have this global, and this is the user-specific configurations for the operating system. And the last one is the local. The local is the configuration made for a specific Git repository. Each level overrides values in the previous level. So configuration in local overrides the global, and the configuration in global overrides the system. The first configuration we should do after installing Git is to set our username and email address. This is important because every Git commit uses this information. So let's set this configuration globally. So running git config and defining where we want to store this configuration, and 2 dashes global. So this will be stored in global. And the next part is the configuration key. And we are going to set the user name. So this is separated with dot, user.name. And the next is our value. And I'm typing my name. So if you have space in your value, then you should be typing it in the double quotes. Hitting enter. So we have set the username. The next configuration is, again, running git config global. And this is for user.email. And I am typing my email address. This one. We set this config globally, so Git will be using this information whenever we commit our changes in a repository. But again, this config can be overridden with local configuration for a specific project. We can check our configuration with git config --list. Here in this list, we may see same configuration key more than once, like this one. We have right here, and we also have it right here. The same configuration key can be listed in this list because the source of this configuration are different. So it is gathering the configurations from the system and the global, and if it exists, it's getting the configuration from local. And in this overlapping configurations, Git is using the last value. So for this one, the AutoCRLF configuration is applied as false. We can list the configuration by also showing where they are coming from with, again, git config --list --show -origin. So here we see the configurations are coming from which specific file. This is for the system configuration, and this is for my users global configuration. We can also check what Git thinks a specific key's value by typing git config, then the key, like core auto crlf. So here we see the value is false. We will be setting some of the configurations throughout the course, so we will be practicing this part more in the next sections. There are 2 ways to have a Git repository. In this section, we will see the first one. We will turn our local directory into a Git repository. Later, we will see the second way, how to clone an existing Git repository from elsewhere. Now let's create a directory here. Let's call it Playground. And let's open this folder in terminal, git bash. Now we will run git init right here. And here we are receiving this message, initialized empty Git repository in this folder. And we have this .git folder created in Playground. And here we see the folder, and this is a hidden folder. And this directory is containing all of our necessary repository files. At this point, nothing in our project is tracked yet, so we have an empty repository. We will not go into the details about what is inside this directory, how it is structured, what we have there, because those are the implementation details, and later version of the Git, these implementations may change a bit, but from a user point of view, our interactions will be remaining same. By the way, we have initialized our repository from an empty directory, but we could also initialize a repository in a folder where we have files in it. So we have our repository. Next, we will see the basic workflow of the Git. Now open this folder with Visual Studio Code. And we have this playground, and for now it is empty. Now let's create a file under this playground. Let's call it index.html. This is a basic HTML, which will have a head in it, and a body, and the head will have the title, and let's say our title is learning Git, and in the body we will have this text, let's say hello Git. Let's indent these parts to make it more readable. Saving this file, and let's open it in our browser. So this is our page. This would be helpful to visualize the evolution of what we are doing. We have this basic page saying this hello Git. From Git perspective, a file can be in one of two states, tracked or untracked. Tracked files are files that were in the last commit in Git repository. Basically, they are the files that Git knows about. And untracked files are any files in our working directory that were not in our last snapshot and are not in our staging area. There are three working areas in Git. First one is this playground folder, which is called as working directory in Git terminology. We have our files right here. And the other two areas are created after Git Init. And one is the staging area, which is also called as index, and the other one is local repository. Staging area contains a snapshot of a file if we specifically add that file to it. And the local repository is where all our changes history is stored. Now we have this new file in our folder. So from terminal, let's go to playground folder. Now we are going to run git status. We will use this command a lot. This is showing if there is any difference between our storage areas. We can see that our new index.html file is untracked because it is under the untracked files output. Again, untracked basically means that Git sees a file we didn't have in the previous snapshot. Git is not going to start including them in the snapshots until we explicitly tell it to do so. This is a precaution to eliminate accidentally including other files in this repository that we didn't mean to include. We want to include this index.html, so let's start tracking the file. To begin tracking the file, we will run git add index.html. Now let's run git status. Now we see that our index.html file is tracked and it is listed under the changes to be committed. This git add command is taking a path name for either a file or a directory. If it is a directory, the command is adding all the files in that directory recursively. Now we updated our staging area with the changes we want. Now let's move this change to our Git repository. So we will run git commit. This is opening the Vim to type the commit message. It may be hard to figure out how to use Vim. To type something here, we hit I, and we are switched to insert mode. Then we type whatever we want. Let's say commit message here. Then to save these changes, we hit escape. Then we hit colon. Then we type W for write and Q for quit. If you would like to abort this commit, instead of write quit, we will just type Q and the exclamation mark. So this will be forcing quit without saving. And let's see what is going to happen. Here it's saying aborting commit due to empty commit message. Now let's run git commit once again. Now hitting I, typing our commit message, let's say this is create index HTML. Hitting escape, colon, write, quit. So we have this output. It's basically saying one file is changed and there are 8 lines of insertion. And here we see the information about our branch. Later we will get to it. And we have this commit ID and our commit message. So we have completed our basic workflow right here. So if we summarize what we have done so far, we have this working directory, staging area, and local repository. And we add the file index.html. Then to add the file to staging area so that Git would be tracking this file, we run git add command, and a snapshot of this index.html is added to staging area. Then to push these changes to local repository, we run git commit, and the index.html snapshot is also added to local repository. Now we will practice same workflow again to see what other options the tools are providing and what other tools are there. Let's change this hello Git part in this index.html. Let's make this a header h1, the main header in HTML, and let's change the message. It was hello Git, but let's change it to Git cheat sheet. And also let's style this part. Let's add a CSS to our project. Adding a style sheet. And this is where the CSS file be stored. We will have a CSS folder, and under that folder we will have this style, let's say style CSS. And let's create CSS folder and style CSS right here. And let's say we want this h1 to be, let's say h1 will be in color blue, and let's say the font size will be 72. Now saving all these changes, and let's refresh our page here. And here we have this blue header for Git cheat sheet. Now let's run git status right here. This time we have 2 files listed here. The index.html status is modified because index.html is a tracked file, and since last commit it is modified, the status of this file tagged as modified. And we have this untracked style CSS. We have just created it. So by default, Git is not tracking new files. Again, Git won't be including this file in our commit until we explicitly tell it to do so. By the way, there is also a compact output version of this git status. If we run git status -- short or just -s, we will be getting this output. Now we see these 2 files in this list again. If a file is new, which means not tracked, it has this double question mark. But if a file is tracked and it is modified, we have this letter M for modified. It may not be so clear, but this short status indicator part actually has 2 columns. Left-hand column indicates the status of the files in staging area, and the right-hand column indicates the status of working tree. Git status is providing information about the changed files, but sometimes you may need more than just the file names. If you want to know exactly what we changed, not just which files were changed, we can use git diff. It shows us what have we changed but not yet staged, and what have we staged that we are about to commit. Git status answers these questions very generally by listing the file names. Git diff shows us the exact lines added and removed. Now let's run git diff right here. And here we see the diff for only modified file, index.html. Git diff is not showing the diff for untracked files, and by default it is showing the modified unstaged files diff. That comment compares what is in our working directory with what is in our staging area. The result tells us the changes we have made that we haven't yet staged. Now let's add these files to staging and see how the output changes. So we run git add index.html, and for the style CSS we can run git add CSS folder style CSS, or just the CSS folder. If we add a directory, the command adds all the files in that directory recursively. Or instead of adding these files individually, we can add all the files in single add command with git add dot. So this would be adding all the files to our staging area. So running git add dot and running git status. And here our files are under changes to be committed, the index.html and the new file style CSS, and we have this modified for the index.html and new file for the style CSS. And if we run git status-s, now the left column is filled. This is indicating that these files are in staging area. And again, index.html has m, which means modified, and style CSS has now a instead of question mark, and a means added. Now our files are in stage. We can use git diff for stage files also. So we run git diff -- staged, or we can run with cached. These are same. And in this output we see the style CSS, and if we scroll down we see the HTML differences. And by hitting Q we are exiting this diff view. Now both of these files are staged and will go into our next commit. At this point, suppose we remember one more change that we want to make in index.html before we commit it. Now let's open index.html once again. Since we are creating a cheat sheet, let's add the comments we know so far. So adding the comments below this header. So in this div, the first command we used is Git Config. Then we have Git Init. Then we have this Git add command. Then we used Git status. We had this Git commit. And also we have this Git diff commands. So these are the commands we have executed so far. Saved the file. Now we are ready to commit, but let's run git status one more time. So here running git status. Index.html is listed both under this change to be committed and change not staged for commit. This is occurring because Git stages a file exactly as it is when we run the git add command. If we commit now, the version of index.html will not contain our newly added parts. So it will not be containing these comments. When we run the commit, the version of index.html in staging area will be committed. We will add this new version of index.html to staging area again. But before that, let's run the short version of git status again. So git status-s. Now for the index.html, two columns are filled with m, which means index.html has modified version in stage, and also we have a modified version in our working directory. And if we run the git diff again, we will see the diff of unstaged changes, which is index.html has this comment list. It is important to note that git diff by itself doesn't show all changes made since our last commit, only changes that are still unstaged. If we have staged all our changes, git diff will give us no output. So let's add index.html once again and running the git status. Now all our changes are under this changes to be committed part, which means we have nothing unstaged. And if we run git diff, it's not printing out anything. Now let's commit these changes. Again, let's run git commit. Again, this is opening the Vim. Let's abort this part. Let's quit from this Vim. As we have seen before, Git has configuration and the editor is a configurable value. Let's override that configuration value. We can set the value global or local. It is totally up to your preference. I will be doing this change for this local repository only. Let's change our editor from Vim to Visual Studio Code. By the way, in my workstation, Visual Studio Code is in environment path, so I can access it like this, code-v. It's going to be printing out the version of the Visual Studio Code. So I have this version 1.50. Let's clear this part. Now we are going to set the config value for core editor. So we will run git config. And again, I'm going to set it for local repository. So adding 2 dashes, then local. And the configuration parameter is core.editor. And again, we will be adding our value having a space, so in double quotes, we will run code space dash wait. This wait parameter is for waiting the console at this line until the Visual Studio Code is completed. So it will be opening the Visual Studio Code for us to set the message for the commit. Then as soon as we close that window for the Visual Studio Code, it will be going back to this line, this command line operation, and then it will be going on from that point. So hitting enter, and if we run git config -- local with L for listing the local configuration, here we have the core.editor and it is code -- wait. Now let's run git commit. So it is opening the editor, and instead of Vim, and here we see the commit entry screen is opened in the VS Code. So that is how we replace the core editor. So this output is just showing the git status output, like we have this new file and the modified index HTML. But we can also get more information in this page. So let's do that. Let's abort this commit by just closing this window. Now it is saying the commit is aborted. Then we will run git commit once again with the option of v. And now in this commit window, we have the changed files, but also the diff output for these files. So in the style CSS, we have this h1. And in the index HTML, we have the reference to this style sheet and the changed lines of the header and the commands. So right here, we can set our commit message, like let's say change header color. We can just commit with this message, or we can add multiple lines of messages right here. So the first line will be considered as a subject for our commit, and then we can add body for the commit message. All we need to do is just to hit enter here and leave one line also, so hit enter twice. Then we can type our message body. Let's say CSS file is added to set color and size, and also we can say add list of commands. So saving this one and closing this window, and here we see the commit message printed right here. Now let's run git status, and it is saying nothing to commit, working tree is clean. This means we have a clean working directory and none of our tracked files are modified. Git also doesn't see any untracked files. Now, to look back and see what has happened in this repository, we will use another tool of Git. We will run git log. By default, with no arguments, git log lists the commits made in this repository in reverse chronological order. The most recent commits show up first. Each commit has its checksum, the commit ID, and the author's name and email, and the date of this commit, and the commit message. And here we see our commit subject and the message body. Now try to get the habit of creating quality commit messages. This would be making collaborating with others easier. Commit messages should start with a single line that is no more than 50 characters. And capitalize the subject line. Do not end the subject with a period. Write your commit messages in the imperative, like fix bug, and not fixed bug or fixes bug. And if you want to add more explanation about the commit, add a blank line after subject, then wrap your body at 72 characters. Now there are available options for git log, and one of them is this git log --patch or -p. With this option, commit logs will show the difference introduced in each commit. This is very helpful for our code review or to quickly browse what happened during a series of commits. And again, we can exit from this git log scroll output by pressing the Q. By default, this log shows all the commits from last to first. We can limit this output. We don't have too many commits yet, but let's show this limit functionality. We can run git log and we can limit it to -1. So this will show only the last commit. And if we change it to 2, it will be showing the last 2 commits. So let's try with this one. Here it is listing just the last commit. And if we type 2, it's going to be listing last 2 commits. We have only 2 commits, but if we set the number higher than the existing commits, let's say we will list last 100 commits, it will be listing the existing commits. It's not going to fail. And there is another option for printing the commits shorter, and it will be printing only their subjects and their hashes. So we run git log --pretty, and it is equal to 1 line. So the commits are listed like this one, and we have the commit subject, change header, but we have more body right here. In this shorter 1-line version, we only see the subject, and that's it. We can create our own formats like this. Let's say we want this git log to be pretty, but instead of 1 line, we can define our own format, and our format is the colon. We define our actual format in double quotes. Let's say first one is the commit ID. The H represents that commit hash, the shorter version of it. Then let's add a dash to output, and then let's add the S. This is representing the subject. So this part, change header color to create index.html. Then let's say we will add another dash. Then in parentheses, let's add the committed date, but we will get this date relatively. So it's going to be printing out 2 days ago, 1 week ago, like that. And the last part is, let's say we want this author email address. So hitting enter. And here we see the commits are listed like this. We have this commit ID, we have the commit subject, the relative time, and the author email address. We can also print this output with colors, just copying and pasting right here. We say we want this to be formatted, and we use this capital C for color, and in parentheses we say this part is going to be red, and this is the hash. This this hash. Then we want this part to be yellow. Then we have the subject, and we have the relative time written in green, and we have this author email written in magenta. Let's see the output. And here we have the output. This is representing the head and the branch information. And here we have the commit hash, the branch pointer, and the message subject, and the relative time and the author email. For more format options, you can check this page. It has the samples, and it is explaining what options exist. And here it is saying what of each the keys are representing. So you can create your own format by going over these options. In previous part, we have seen how we can create our custom log output. And that command is not easy to remember. Fortunately, Git is allowing us to set alias for commands. So instead of typing this command every time, we can define an alias and use it. This can be global or local configuration again. So defining a configuration with Git Config, and again I'm going to set it for the local, and our configuration is alias then, and let's say we want this to be LG, and we will pass the part from here, just copying this part, and in double quotes adding this part. But again we have this double quotes right here, so changing that one to, let's change it to single quote, then changing this one to single quote also. So with this way we are adding the part after the log and the parameters to our configuration as an alias. And by running git lg, we will be getting the same output.